Good day to all of you. Today we'll do our last lecture on slurry ponds, and we will address the issue of environmental control measures at slurry ponds. So, in your mind, what are the issues, environmental issues or environmental problems associated with slurry ponds? Would anybody like to say what are the problems associated with, which is the main one which comes to your mind? Suppose I have an ash pond. What is the main issue with ash pond? So if the ash is dry, in the dry months there may be dust emissions. So that's one problem. Any other problem? Environmental problems from slurry ponds. We saw that the decanted slurry, which normally is either recirculated, but if it is not recirculated, it goes back to the water source. So the decanted slurry is sometimes milky in color. So there is this issue about suspended fine particles, total suspended solids. So sometimes the total suspended solids is also an issue. Any other thoughts which come to your mind, or any other issues which you think would influence? Well, it may infiltrate into the groundwater, but if the water is okay, so infiltration into ground. So if the leachate or if the pore liquid, if the pore liquid is not of good quality, then you have an issue. If the pore liquid is all right, then there may be another related issue which we'll look at. So let us see, these are some of the factors which come to your mind in an overall context. What are the environmental issues that we look at? So if you look at an ash pond or a slurry pond, we talked about fugitive dust. So the dust is not going to come out from the ponded area, the dust is going to come out from the dry area. And our tendency is we should keep the pond as small as possible so that the phreatic line is not high. That can be a problem. But if you are very close to habitated areas, then you might want to run your slurry pond by keeping the water level high. Excess suspended solids in the decanted water is also another problem. As somebody said, leachate into the ground. Sometimes the concerns are expressed that there may be some deleterious salts or material in this. So one issue is that those will go with the leachate to the groundwater table, but more importantly, if they also come out, then they can affect the crops adjacent to it. There's not enough evidence to say so, but since this material is not natural material but more man-made, either by burning of coal or by various processes involving crushing of the rock and then chemical additions to extract the metals, sometimes there is an issue that some of these deleterious material will come out and affect the plant growth, or it will be taken up in the roots of the plants. Occasionally we do have the problem of overtopping, which is more a stability problem, but what is the difference? Suppose I have a water reservoir, right? Suppose I have a water reservoir and I have overtopping. Overtopping will occur if the spillway capacity is not adequate, or if there is a large rain which comes and you are already full up and you don't have adequate freeboard. Overtopping normally occurs when your ash is almost full. Slurry pond is operating at its full capacity and you have a huge downpour and your spillways are not having adequate capacity. So if I have a water reservoir and if it overtops, the water will come out, right? It might breach the embankment, that will become a stability issue, and then it will flood the adjacent areas. So if water comes out from a reservoir, it will flood the adjacent areas, right? But eventually the water will flow away along the natural drainage paths. So temporarily it will flood the fields, but after about a week you will find that the water has gone away, because all ground has some natural drainage paths taking you somewhere. When overtopping occurs with ash, the major problem is the water will run away, but the ash will get deposited in the adjacent areas. Now it's not so easy to remove the ash, because now the solid powdery material has settled down on the ground surface of the nearby areas. So overtopping of slurry has a much longer permanent effect than overtopping of water. Both may have impact on the habitat around it, the crops around it, but the permanence, that once slurry has come out, it has and I have told you slurry can travel several hundred meters and sometimes kilometers. So if you have, say, slurry ash has traveled 1 kilometer, or mine tailings have traveled 1 kilometer, and suppose it's a farmer's field and you have some wheat crop growing in it. Now what happens? That material gets settled in the wheat crop. If you have to bring back that material by an earthwork operation, the crop is lost. Of course, even if there is flooding, sometimes the crop will be affected, but at least the water will go away. So that's the major issue about overtopping in slurry ponds. If I'm doing disposal in the dry manner, then of course there is larger problem of fugitive dust emissions, and there's also problem of erosion from these slopes during the monsoons till the final cover comes. Once the final cover comes, then the problem of erosion is not there. Is there a problem of erosion in the pond, in a slurry pond? Well, we are making these embankments and they have a cover soil, and you are supposed to have a vegetative growth on it. So erosion is not a major problem in ponds if your embankments are well designed. But in dry placement, the slopes are exposed till it reaches the full height, and there can be erosion and there can be fugitive dust. All other aspects are similar. So if I want to address the environmental concerns, I have these few issues: effect on local air quality because of dust, effect on surface water quality because of total suspended solids, effect on groundwater level and groundwater quality. So these are two issues which are separate. If I have got deleterious material, or if I have got contaminants in the water, if the pore fluid quality is not good, then I can affect the groundwater quality. But the other issue is I may also sometimes affect the groundwater level, and that also may have its own associated problems. If the dust is taking away ash, what is the effect on local soils and biotoxicity? Occasionally you will hear, and I mean last year there was this big news item that the apple orchards in Himachal were being affected by ash from a nearby plant. What was happening was that during the pollination period, the ash particles were settling down on the plants, and that was affecting the pollination, conversion of the flowers into fruit. So while it looks very innocuous, it's a very mild thing, small amount of dust, but in an area which is not having dust in the past, if you start creating an environment which has small particles floating around, it can affect. So it can affect the local soils or biotoxicity. You have the issues of seepage and waterlogging because you are creating a pond. You may sometimes affect the surface water drainage pattern of the area, just like in landfills. If you are making your pond in low-lying area, normally the low-lying area is a drainage path for flows in high rainfall months. So we have to take care of that. Site washout or overtopping is of course an important issue. And finally, long-term stability. When you and I have walked off the pond, the plant has stopped operating, who is going to look after it for 100 years, 200 years, 500 years? So let's address this. The first question is how to prevent fugitive dust emissions during dry summer months. And it's simple. You can do ponding. So if you are in an area where the dust is causing a problem, you have a road highway next to the pond and you get these huge dust emissions, or you have some houses nearby. So you can increase your ponding as long as you are having excess water supply. That means don't operate the pond in the summer months at a low level, increase it and keep the majority of the ash submerged. One can also say I can sprinkle, but sprinkling is 24/7 sprinkling is a very, very costly exercise, and it is power dependent. So I have not seen sprinklers which can keep the dust subdued 24/7. You may do sprinkling while you are there. You may have automated sprinklers. The idea is to keep the dust down, but 24/7 sprinklers working on any area I have not seen. Of course, when the pond reaches its top level, then you should grow vegetation on it, either by putting a soil cover and vegetative growth, or if even on that material the shrubs can grow, then please accelerate that vegetative growth, because any form of vegetative growth will be a dust control measure. And of course, sometimes you might want to use intermediate soil covers. That means you have a material which is going to go to 15 meters high. You can build in an expenditure that after every 5 meters, I'll put in an intermediate 6-inch soil cover, so that the dust is not, the ash surface area is not exposed. This intermediate soil covers works more when you're using as a construction material in embankments. Then you don't want to leave very large patches of the ash exposed in a dry condition. Surface water quality, we have addressed this issue. How do we prevent suspended solids in the decanted water from reaching local water bodies? See, if the size of your pond is correctly designed, then the finest particle will settle and you will have clear water coming out. The problem comes when the size of the land available to you is smaller than the design size. Then you have a tendency for the coarse particles to settle, but a certain set of particles will pass out. And really for that, either we need additional sedimentation chambers, or we talked about filters last time, filters which become choked and which have to be periodically cleaned, or we can actually make an end of the decanting pipe and a treatment plant where you flocculate all these fines and deposit them. It's very expensive. And of course, finally, recirculation means that you are not releasing any water into the body, into the surface water body nearby. But recirculation you can do for a limited period of time. The material keeps on getting built up in the slurry water, and eventually you have to do a blowdown or you have to release something, and at that time you will have to need all these alternatives. So even today, sometimes when I walk to an ash pond, I'm often seeing when the pond is full. You see, when the ash is down, then even if the horizontal travel time is not adequate, you can close the lower ports so that the water level also rises, and therefore there is a time for horizontal travel and a time for the vertical rise. So you can have more retention time. But when the pond is almost full, then you are not able to hold any more water. So that's the time when you find the emissions becoming high. In terms of groundwater, there are two issues. One is preventing the rise of the water table, and the other is the deterioration of the water quality. And if I look at the issue of rise of the water table, I just want to appreciate it. If you make a slurry pond in an area where there has never been a water reservoir in the past, your water is coming either from a canal or from a river. It may be 20-25 kilometers away, and now you have made this pond, which is like you have created a lake. So maybe in the original site, the water table is deep below. Maybe the water table is deep below, and you create a ponded area, And remember, this is going to work for 25 years. So you're going to have water most of the time in the pore 25 years. So if there is no barrier to downward flow, that means not impermeable soil or very low permeability soil, then this water will tend to flow down. Some will be held, some will reach down. And if a lot of water is flowing down, this water table may become something like that. There may be a mound of water. The water table may rise a little bit in this area because a lot of water is coming. Eventually it will just flow away. When the pond will stop functioning, the water table will come back to its original position. If my water table is here to begin with, then I have to be very conscious of the problem. Because then this water table and this will get interconnected. The water table rise may be like that. And this water table may rise. Now, as long as the water table rise is beneath the pond, it's fine. But if the lateral permeability of the soil is high, the water table rise may start to extend beyond the pond. And I'm not talking of the seepage water which is through the embankment. I'm talking of the water which is going down. Now, when this water table rises, sometimes it brings up the salts from below, which were not in the crop zone, root zone of the crops, up. And that sometimes has an effect on the production of the crop output. In some cases, it may be very good. If you are in a water deficient area, what have you done? You have started giving more water to the area. Assuming that the water quality is not affected, the farmers around you are happy. There is more water in the tube wells, there are more water in the irrigation wells, so that's good for them. You are in an area where water table is already aplenty and close to the ground surface. You are doing the opposite effect. They don't want more water, they don't want the water table to come higher, but we are making it go higher. So this causes the water table to rise. It can be beneficial in a water scarce area. It can be problematic in a high water table area. So the one thing that we have to realize is, as you will see here, that if this is the original groundwater table, this is the original land, I have come and made my ash pond or slurry pond, my water table has risen, it has become connected. So after some time, when the ash pond or slurry pond is not being operated, there will be no water. You will put a soil cover, you may put some vegetative growth on top, and then the water table will return to its original position. But for these intervening 10, 15, 25 years, you can have some effect of raising the local water table, and that you have to take into account. So what about the quality? Before we look at the next issue, what about quality? Water quality will depend on the slurry water, that is, are you getting treated water? Are you getting raw water from a river? Is the river water itself in the summer months having high contaminants? Now, normally the water that you get for the purpose of making a slurry or for the purpose of chemical processes may not be a very high quality water. So then what you are doing is, you are picking up the water, making a slurry and depositing it on land. So if the water quality used for making the slurry is bad, then it can impact the groundwater quality. The other is, no, inflow water was good, but my tailings had some residual chemicals, and those chemicals are now mixing with the water and going down. So this is a very waste material specific problem. For a long time, there has been a huge debate that does the groundwater quality get affected by burning ash, by burning coal and using the slurry technique of depositing the ash. Does the quality of the liquid in which the ash has been mixed with the water, does it affect the groundwater table? And there have been so many studies which show there is no effect. If there is an effect, it may be because the original water quality was itself bad, More recently, in the US, they have started saying that no, in a few cases, they have seen a rise in some specific heavy metals around ponds which have been in operation for several years. So there are marginal increases beyond the acceptable limits of some heavy metals in the US which have been reported. So this aspect has to be studied very carefully. If you are using mine tailings, what are the processes? You have to do the toxicity characteristic leaching procedure, that the ash or the mine tailing should not have anything which can leach out, and then see how it affects the groundwater table. So the only way to stop the groundwater quality and the groundwater level from being affected is by putting a liner at the bottom. Okay? And please understand, I can do three things. I can say that my leachate is coming down. I already have an impervious stratum here. I can put a cut-off trench and an upstream clay core and constrain this water in this area. This is one approach. The other approach is let this water come out. As it tries to go beyond the embankment, I can put a vertical cut-off wall, and we'll be doing this in the next few lectures, and I can do an extraction well, and I can put it back here. That means the effect of this water is not going to extend beyond this wall. And the last is, let me not allow the water to get out. So this is the best. And it's, while the word used is liner, it means it has to have bottom drainage also and liner. Because otherwise, I told you, incremental raising is very, very difficult. So purely from the point of view of affecting the groundwater, both in terms of the groundwater table level as well as in terms of the quality, you are safe if you use a liner with the bottom drainage. However, it's expensive because the size of these ponds is huge, 2 kilometers by 2 kilometers. So that's a very expensive bottom barrier that you have to create. But there are no options at the moment. There is a ministry guideline saying you must put a liner at the bottom. Doesn't give the details of the liner, so people will put some thin plastic sheet to meet the Ministry of Environment and Forests guidelines. In the US now, they are now specifying the requirement of liners and bottom drainage. The rules have just come out in October 2016. So really, if you are looking at groundwater quality as well as the groundwater level, bottom drainage and liner is a good thing. Even if we have taken measures that the groundwater will not rise, we still have sometimes the issue of waterlogging. And waterlogging is normally due to the seepage from the embankment, not from the base. It can be accentuated from the base as well, but if you don't collect your seepage water properly and don't connect it to a surface water drain, then what will happen is, suppose in plan I have a rectangular pond. In some area, the water may start to seep out and collect outside, and that causes waterlogging. So to prevent waterlogging, best to have cut-off trench, which I showed, or vertical cut-off walls. Liners, of course, are the best solution. But in any case, your surface water drain or the interceptor drain outside the embankment should be able to take away this water and connect it to the local drain from which the water flows away. So efficient collection of the seepage water is important, and measures that nothing from the bottom comes to the sides are also important. And we've done this surface water drainage issue, blockage of the surface water drainage path, that if we are in a low-lying area, we normally don't consider this, but we have to make diversion channels. So if I'm in a low-lying area, let us say I have a concave upward shape, and the elevation of the ground on one side is higher, on the other side is lower, and you have made your pond or a landfill in between. If I do that, I have to give channels at the side so that the water which comes from behind during the rainy season is not stopped by this whole mass of waste disposal facility that you have created, but it should be able to go from the sides, bypass this, and meet this in the front. So we have to create alternate flow paths so that there should be no ponding of water behind it. So if I'm looking at in plan, let us say this is a low-lying area, and I have used this area for the purpose of creating a pond or a landfill. Now when the flow comes, there will be ponding of water behind it. Instead of that, I need to have alternate paths in the form of channels so that this flow continues uninterrupted and does not cause ponding upstream of these facility that you have created. Finally, we would like to address the issue of long-term stability. I have made a pond with all these measures that we have talked about here. The only question is, are we bothered about long-term stability? Long-term stability means when human intervention stops. I don't have a maintenance engineer on it for life, or I'm not going to have a maintenance engineer there for 100 years or 150 years. Then the facility, what you have created now is a topographical high. You went up, going higher and higher by the upstream method. There was no topographical high in that area before. You make the embankments, you put some vegetative grass, you go away, nobody irrigates the grass begins to dry up. So you must have something which is stable for at least 50 to 100 years after being abandoned. So one is the top surface. We have to put soil on it and do vegetative growth. And the other issue is also on the sides. Any measure of vegetative growth which is assisted by irrigation will not survive. So all vegetation has to become self-generated vegetation. That means the local shrubbery and the local vegetation has to be put in position. The only last thing that is bothersome is that the material that you have deposited between the embankments by the upstream or the downstream, that's a soft or loose material hydraulically deposited. Should we densify it before we move on, or should we leave it loose? That's the only question. So densification is not easy or cheap, but if you remember your ground improvement techniques, in situ densification of coarse-grained soils or silty sands and sandy silts, you have a few alternatives. Do you remember those alternatives? Impact compaction, vibroflotation, compaction piles, blasting. The idea is, I have created a mass 1 kilometer by 1 kilometer, say 20 meters high, which is relatively loose. If I don't densify it, the top surface will eventually settle with time. So one is to have adequate convexity in the closure. So if final profile is like this, so I should give adequate convexity at the top so that always the surface water is running away. And the other question is, should I densify? If you can, why not? And as I said, it should be self-generative vegetation. So long-term stability implies in situ densification, self-generative vegetation or rockfill. If you cannot get, suppose you're in an arid area, dry arid area, Rajasthan, and you don't have self-generative vegetation there, then you might have to put a riprap or an armor, a hard material which doesn't blow away, which doesn't have erosion. So eventually, an engineered closure of a slurry pond, a liner and a drainage material here. These are your upstream raisings. You had the soil cover on it. You have to have vegetative growth. You have to have a soil cover on the top. You have to have vegetative growth. You have to have densified. If you intend to densify, the cheapest and the method for densification is blasting. Because blasting is like creating artificial vibrations and densifying. It will not be uniform. So don't think that after blasting you're going to get very uniform compaction. When you're going to build buildings on it or when you're going to build any structures on it, you'll still have to locally densify that zone by vibrofiltration or compaction piles or whatever you want to do. But as a mass, if you want to densify the material, then do blasting so that this mass remains stable later on. So what you do to this will depend on where you are. You know, there is an ash pond of NTPC at Badarpur in Delhi. The land prices are huge. So the real estate industry wants that land. You have already reached the final height. It's at an elevated height of about 20 meters. On the top surface area, let us say that it is 1 kilometer by 1 kilometer. Everybody says I can build a building. So you say no, it's on loose deposit, 20 meters deep. So what? I'll put a 30-meter deep pile or I'll densify this, because the cost of land is so very, very high near to Delhi. So for those ponds or those waste disposal facilities which are not hazardous, because on hazardous material people are very reluctant to allow usage at the top, but those which are not hazardous, you are able to take in situ densification measures because the land value goes up. Whereas that may not be possible in a remote pond which nobody else is going to use for real estate tomorrow. So actually the measures that you take are dependent on the additional value add that you will get and how you will use that pond later for what purpose. So remember that there is the cost of environmental protection. During operation you have to protect it, because after the operation the water is gone. I mean, unless you made the mistake of leaving it finished in a concave upwards or a flat section which would settle with time at the center, so that if you leave it concave upwards by mistake, when the rain comes it will all accumulate at the center of the pond. When it accumulates at the center, it will go down into the pond, and again you can have an artificial water table inside it. But if you have done a good closure, then after the closure there is going to be no water in the pond. Firstly, it's topographical high. Secondly, it's convex. It's got an earth cover and vegetative growth. Water will run off it. So stability is not going to be a major issue. But during operation, stability is always going to remain an issue. During operation, total suspended solids in the decant is going to be an issue. So environmental measures during operation are different from the environmental measures post-closure and post-abandonment. Just for a minute think that your vegetation doesn't survive. Suppose you put some grass, even a local grass, but for some reason the vegetation doesn't survive. So vegetation goes and the soil cover gets exposed. Even that is fine. But if rainfall starts cutting gullies into the soil cover, right, progressive gullies, and you're not there to maintain it. If you're there to maintain it, fine. Then the gullies will eventually expose the ash inside. And that becomes a problematic because ash is highly erodible. And then it will start to come into your waterways. So we have to keep all these into account. So if I look at a 1 kilometer by 1 kilometer into 10 meter high storage, and if I see what is the cost of disposal in a slurry pond versus a municipal solid waste landfill versus a hazardous waste landfill, which one do you we are not doing transportation costs. Once the material arrives at site, which do you think will be the least costly? Slurry disposal versus hazardous waste disposal versus municipal solid waste or non-hazardous waste. That means you're talking of the cost of spreading and compacting the material, cost of liner, cost of cover, final systems. So just see, there are some relative prices which this was a study done in 2005. You see, when you have slurry waste, it spreads by itself. So you don't have dozers and compactors which are running on the surface. So that's the power of gravity flow of water is used for spreading the ash. So therefore, ash disposal, even if it has a liner and a basal drainage, is relatively less compared to municipal solid waste, which has to be spread and compacted, and less than hazardous solid waste, which has to have a double liner. So the cover and the liner of the hazardous solid waste predominate the cost. So typically in 2005, the rate for hazardous waste disposal was about 500 to 800 rupees per ton. The rate for municipal solid waste disposal was without land costs, please note. And the cost of disposal of ash was lower. So slurry ponds have lower cost of disposal, but there are so many issues associated with availability of water and recirculation of water. So in the end, I'd like to say the following, that the first mantra is minimize waste. So just remember, go back to your integrated solid waste management principles. Maximize the utilization of ash or tailings or waste. Can everything be used? As soon as the material becomes characterized as hazardous waste, please understand this. Suppose you have a mine tailings and it is mostly crushed rock. It's soil-like material, but it has something which is sitting on the surface, which is leachable, and by the TCLP test, it becomes classified as hazardous material. You can't use it. You can't use it without stabilizing it. So as long as the material is non-hazardous, we are basically dealing with silty sand and sandy silt. We can use it in earthworks. So maximize the utilization of ash or tailings or waste to the extent possible. Geotechnical use of pond ash tailings in earthworks is the most economical. You know, people say I can use it in cement, I can use this material to make bricks, I can use it to make blocks, everything fine. But you want to use 10 lakh cubic meters of ash or 10 lakh cubic meters of non-hazardous tailings. The simplest is maximum utilization in embankments. So what embankments do we usually construct? Road embankments, or we fill low-lying areas, or we may have a lake embankment. Road embankments are the one which use the maximum amount of material for the purpose of earthworks. So you can use it. But your pond has to be close to the road. You can't say, all right, sir, I'm making a road from Delhi to Meerut. Can I get the ash from, say, 500 kilometers away? No. Then the local contractor will say, my local soil is cheaper, the cost of transportation is very high. So nearby your waste disposal areas, utilization in earthwork is the actual way of keeping environmental costs control measures to a minimum. So always invest the maximum in utilization. Even if we have to pay a little, it's better than creating these huge ponds. So maximize utilization of waste. Never mix waste. Again, we go back to our mantra from integrated solid waste management, that if you are producing fly ash separately and bottom ash separately, don't mix them together to form a slurry, because then you can't get them individually. You can still use it, but if both are kept separately, one can be used as sand, as a drainage media, the other can be used for other applications. So keep the materials stored, even if you are not utilizing all of them, keep them stored separately. Geotechnical use should be your first choice. In many of the Delhi metro construction projects, where these stations had to be made, a lot of earth filling had to be done for the Delhi metro. And in those stations, as well as in the tracks, a lot of fly ash was used from the local ponds. Badapo, Indraprastha, we emptied out the ponds. The whole pond was emptied out in utilizing this ash. But they were nearby. If these ash ponds had been lying, say, 200 kilometers away, we would not have been able to get the ash in. unless it was still cheaper than local soil. So, use of fly ash in cement and pond ash tailings in building materials is also an option, but they are value added products. If you want to use fly ash and cement, what do you need nearby? The fly ash should be nearby to the cement plant. Again, you can't get fly ash from 500 kilometers away and put it into a cement plant 500. So, the proximity of the production unit to where the waste material is lying is important. And please never use the materials if they are classified as hazardous. Only use them if they are clearly classified as non-hazardous. It is your responsibility as a geotechnical engineer to ensure that the material that you're using is classified as non-hazardous. And always remember, transportation from plants in remote areas is an expensive exercise. So what you will find is, if you look at the map of the country, those ponds, slurry ponds, which are close to urban areas with high density populations, their material is being used very often. And those which are sitting in remote areas, there's no utilization. So you have a thermal power plant which is in Rihan or in Vindhyachal versus a thermal power plant which is in Delhi. The utilization of ash in Delhi is so very high, and the utilization of the Rihan power plant is so very low, unless by any chance cement plants are sitting right next to you in those remote areas as well. So with these, I think we have come to the end of the discussion. What we have learned is that to keep the environmental impact minimum, have an envelope which prevents the emissions. Whatever emissions come out, if they are decanted water, please ensure that there are no total suspended solids. If the emissions are in terms of groundwater contaminants, then please put a liner and do not allow them to escape untreated. Eventually, both things look the same, landfills and the ponds. But sometimes do remember that if you were to do a hazard risk analysis, then depending on the material which is being disposed, the waste, the same size, the same quantities, if the hazard risk is higher, then the measures will be more stringent, and the hazard risk is lower, the measures may be less stringent. That will come out from a more detailed analysis of the type of waste that you are dealing with. So any questions? Then all the best, and we'll start, I think, a new topic in the next class. We'll be talking of now remediation of contaminated sites. We have not addressed the issue of contaminated sites, sites which have been contaminated by effluent, sites which have been contaminated by leaking drums. We'll look at that next time and see how, as geotechnical engineers, what is our role in remediation or control measures at such sites. So have a good day, all the best.